I welcome everyone from our EveryEng to this demo session of piping material engineering. So, in short, we will try to cover today some different type of components which are used in piping, as well as also we will have an overview of a document which is piping material specification (PMS) and few sample sheets of the wall material specification. So I will not ask everyone to speak, but is it possible for you quickly to write mention your profile in the chat box? Maybe I'll just give 1 minute so that I have a brief idea know about the background of everyone. I think everybody, many of you are from the piping only, but can you just write in the chat box your profile, like your piping layout engineer or the piping stress engineer, piping material engineer, or the from inspection QA/QC. Okay, great. So everybody is from the piping department. So now, because I why I've asked you, because many of our sessions are also attended by the students who are just fresh graduate from the college, and sometimes they don't have any background of the piping, you know. Then we start with a very conceptual from the base. We explain them what is piping, what are different components which are used in piping. So I think many of you are anyways working in a piping, so you are little bit or majorly aware of the piping components, may not be aware of the intrinsic detail of the components. So yeah, today we will see the one of the aspect of the piping, that is the piping material engineering. Yeah. So in a piping department, actually there are three subgroups we have in piping. One is piping layout, which is responsible for the routing of the pipeline. Okay, and generally this is done by through a software, sometimes E3D or SP3D, depending on the company and the client. Then we have a second subgroup, that is a piping stress department. So the main function of these engineers in this department is to analyze the pipings which are routed by the layout engineer from stress point of view, whether those piping can take the stress developed due to the pressure, temperature, and also due to the layout. And the third discipline is a piping material engineer. So today we will focus on the activities which are done by the piping material engineer, and what are the things a piping material engineer should be aware of. Okay. So before give you an idea, myself, I am also a piping material engineer working from many years. I have worked in the projects like refineries, fertilizers, and some chemicals. So let me start with the definition of the piping material engineers. So piping material engineer is a person who is required from the bid stage through design, construction, and mechanical completion stages. So for example, when I say a bid stage, it's like a client want to set up a plant for him as any product. Okay, let us say one example of the fertilizer. Let's say client want to set up a project where he wants ammonia or fertilizer as a output, ammonia, urea, or anything. Then he will ask the different EPC companies to carry out the cost estimation, the feed engineering. So in the cost estimation, the engineering companies, like when you're working in different EPC consultant, they will carry out the cost estimation. Yeah, and that cost will be given to the client, whether that cost is sufficient for a client to go for the project or not, or whether that price is within budget or not of the client. Then what is the role of a piping material engineer in this bidding phase? Okay, so in this bidding phase, when we are doing a cost estimation, so let us say we have in a total plant we have 5,000 lines. So out of those 5,000 lines, which are the materials applicable for those 5,000 lines? Okay. So accordingly, we have to prepare the pipe classes. There is a document, piping material specification. We have to prepare the pipe classes. We have to select the appropriate rating of the component. We have to select the appropriate thickness of the piping. Okay. And also the piping material engineer in few companies assist for taking out the piping MTO, or in few companies there is a separate team for the piping MTO. Those piping MTO designers or the engineers will take out the quantities of the piping components like pipe, valve, fittings from the PNID, and all this data will be consolidated by a piping material engineer in different softwares. Okay, so in the cost estimation phase, we do not have so much of time, as well as the client does not give us so much of money, you know. So we cannot model each and every line in a software E3D or SP3D. We do not have that much time. So it is just based on the PNID, we take out the quantities, and then it is summarized in different formats, either in Excel, or many companies have different their own softwares. So we can feed data in that software and take out the whole consolidated MTO. At the end, the output will be carbon steel pipe 1 inch, 1 kilometer. Carbon steel pipe 2 inch, let's say 500 meter. I'm just giving you the sample case. Or the gate wall 1 inch, 100 quantities. Wall 2 inch, 50 quantities. So all these quantities will be then given to a procurement department. So the procurement department knows price of each and every component. If not, then they will reach to the different vendors in the market and take out the price. Then this whole price of all the MTO will be consolidated, which will be called as a piping cost from the piping department. And similarly, such cost will be developed by the different engineering departments like the mechanical, instrumentation, chemical, every whatever they want to buy, or the civil, which is a major cost, or mechanical also the equipments, and that cost will be given to a client. So this is how a piping material engineer is involved in the bid phase. When you get an actual project, then you have to design the project. It means you have to develop the models in the SP3D or the E3D. For that, now everybody knows, many of you are the piping engineer. So you model it in a E3D. But how do you model? For that, you require some input. So that input is given by a piping material engineer in terms of a pipe classes, in terms of the components. Yeah, and then it will be cataloged in the E3D by the E3D admin. Okay, and then further steps. I will not go in too much of detail because we don't have that much time to discuss everything. So what are the main role of a piping material engineer? It is design. In design phase, what he does, the most important activity to perform the pipe wall thickness calculation. Second, to prepare the PMS, piping material specification, for process and utility services. We will see the example of this PMS document. To prepare VMS, wall material specification. Okay. And what are the other design activities done by the piping material engineer? To prepare the line list. Okay. So in the line, in a project, let's say we have 5,000 lines. So a line contains different data like a line number, size, fluid code, pipe class, insulation type, insulation thickness, pipe routing from, to, its design pressure, design temperature, operating temperature, sometimes the stress analysis number, stress analysis category. So all this data is consolidated in one document and given to a site for the easy reference, and that document is called as a piping list. So it is a responsibility of piping material engineer. Why? Obviously, it depends from company to company. But as a piping material engineer, he will consolidate all the data from the PNIDs as well as the lines which are extra added into E3D. Sometimes they are not PNID because of the utility lines. Later on, they will come on PNID also at the IFC stage. So yeah, and this is also mainly done through different softwares in different companies, or you can maintain the line list in Excel also. To prepare the list of piping specialty items like the stream traps, strainer, hoses, etc. So generally the components like the pipe, elbow, reducer, T, gasket, wall, bolt, we call walls, we call all these components as a standard piping components. Other than this, we have few components like the stream trap, strainer, hoses, or different layout special parts. Like funnel or the bird mesh. These are also included in the piping spec, but they called as the special items, and sometimes it is required to prepare the special part index list, which is used by a site because for the special part, each special part you have to create one data sheet which gives details of that component. It is called as a special part document. So then it is easier for the client and the site people to refer how, if they want to see the details of that component, then they will easily go to the doc ID and open the document. Okay. I will not be able to show you the special part list at this moment. Otherwise, I would have showed you. To prepare the datasheet for the special piping specialty items, like I told you, for the stream trap, it is not a standard component. We have to prepare the datasheets. In the datasheet of the stream trap, we will mention that this stream trap is used for which service, like majorly for the steam. Then what is the design pressure and design temperature of the fluid? Then what is the flow? What is the delta P differential pressure? Accordingly, vendor will select the suitable type also. You know. So all these details are mentioned in these datasheets. To perform the line blank thickness calculation. So line blank, many of you know that spectacle blind we called, sometimes we call it spectacle blind, sometimes we called as a figure eight, or sometimes we called as paddle blank, paddle spacer. So these are actually, it is a standard item, but this is a standard item till 24 inch only. We have different standards mentioned for this. So it is a ASME B 16.48 standard. So in that standard, the thickness of the spectacle blind, it mentioned till 24 inch only. So if you want to use a spectacle blind above 24 inch, then what should be the dimension of that spectacle blind? What should be the thickness of the spectacle blind? So actually it has to be calculated as per ASME B31.3. Yeah. And that's why we have to, as a piping material engineer, we have to do the calculations to arrive at the thickness of this line blank. Or sometimes when the complete piping is erected at a site, we have to do a testing also. No? So for the testing also, sometimes we have to block the end of the pipe and to do a testing. So for that, we cannot use a blind flange every time. So there also sometimes we use a line blanks, and depending on client, it can be just cut from the sufficient thickness of the plate and weld it there. But then what is the sufficient thickness of the plate? That also we as a piping material engineer have to calculate. To perform the reinforcement pad calculation. Yeah. So this terminology is like everybody knows. I mean, obviously we will also see this part when we will see the actual slides of the piping components. So when we want to take the branch calculation, maybe what I would also like to prefer to, yeah. So this is a branch calculation, and to this we have to sometimes weld this additional pad, this material, which is called as reinforcement pad. So every time we do not use this pad. Sometimes it is just hold to this main pipe and weld this branch pipe. We don't require this every time. So whether this is required or not, it is done by the calculation by the piping material engineer. The formulas and all the basis is given in standard ASME B31.3. To develop technical supply conditions or requirement of various piping material and to make technical recommendation. As I told you, first we will prepare the piping specification. That piping specification will be used by the 3D modeling softwares. Then we take out the MTO, consolidate all the MTO. It means at the end we will decide how much quantity we want to order to construct this plant. And then we will go to the different vendors and ask them we want this component. For example, we want 10,000 kilometer of the pipe. Then we will go to the vendor and we will tell them that we want this size and this much length. Okay, but actually this is not sufficient. In addition to quantity, we also have to tell them the exact specification. Obviously, like other than materials, what are the different testing needs to be carried out. Okay, there are so many different requirements, and these requirements are mentioned in different documents, which is generally called as the enclosure. So for each component, for the pipe, we create a different enclosure. It sometimes it's called a technical notes or the enclosure for the pipes. In the document, you will see different many technical requirements are given, like the if it's a carbon steel, then that carbon steel materials shall be normalized, you know, or stainless steel solution annealed. Wherever you want PWHT, you will specify we want PWHT, radiography, all these requirements are given. So that vendor will comply to all those requirements. So these documents also we have to prepare as a piping material engineer. Then as I told you, the bill of material, we have to prepare the piping bill of material, to arrive at the total consolidated quality quantities which we want to give it to vendor and to the client also. To control the piping item quantity, monitor the surplus and shortage of the piping items. It means um, everybody knows that our projects runs for at least 1 year, at least. So let us say our project in the engineering phase, it runs for the 2 years. Okay, then we do not procure the item after the 2 years. From the day one, we will start procuring the items. Okay, but let us say in the first 6 months, I have procured some, let us say 10,000 kilometer of the pipe. Okay, and later on during the phase, I know that okay, actually I don't require 10,000. I want only 7,000 kilometer of the pipe. Then that 3,000 kilometer is the extra pipe. But then if I do not require that extra pipe, I should not pay for that also. So then we have to convey it to vendor that okay, initially we have asked you for the 10,000 kilometer of the pipe. Now our latest quantity is 7,000 kilometer. Can you please reduce that quantity? Or sometimes we want the extra material also. We just say that we want 100 walls, but later on there the addition of the walls, then we require maybe 125 walls. Then we will say okay, we want 25 extra walls. So this addition and deletion of the quantity also we have to track as a piping material engineer. Sometimes in few companies, this procurement is in a scope of there are different engineers, procurement engineers given for this task for the quantities also. Yeah, but many of the organization, it is like piping material engineer will send, or he will also control the quantities, and the procurement engineer will only coordinate with the vendors for the commercial purpose. For the technical purpose, a piping material engineer is responsible. Yeah. So when I say for the technical purpose, it means let us say I have asked for the uh, 10-inch pipe of let us say 10 mm thickness. Okay. Now vendor is saying instead of 10 he can give 9.5 of the thickness. So actually this is a deviation to our requirement. Then as a piping material engineer, it is my duty to check whether that 9.5 is suitable or not. Yeah. So this is called as a technical clarification or the technical decisions. Once I give the clarification that okay, whatever a vendor is offering is acceptable to me from technical point of view, then the procurement engineer will do the commercial negotiations. Okay, then what is your price? Can we reduce the price? With different vendors, he will talk. Okay. So all this is the part of the procurement. So in procurement, what we do, first we prepare the material requisition for getting quotations. Yeah. So I will try to explain you this with some analogy. Let us say you want to buy a mobile. Okay. Then let us say we are not buying from the shop. We are not buying it online. We are buying it from the shop. Then we will go to a shop. Do we say that we please give me a mobile? We don't say we just give mobile. Okay. We tell them the exact specification. Like first we'll tell them whether we want to go for the Android or the Apple. Okay. That is operating system. Then after going for the Android, we have different companies. Okay. Samsung, MI, Nokia and things. So we tell him I want a mobile of this company. Then he will again filter out what should be the screen size. Okay. What should be the RAM? What should be the operating system? What should be the then it has a camera. What should be the megapixel of the camera? You know, or in addition to that, you will say I want battery backup of so many hours or battery of so many thousand mAh. So we give specification to the vendor when we want to buy a mobile. Okay. In similar fashion, when we want to buy a component which is required in a plant to construct, and when we are buying it from the vendor, we have to give this all the different requirements to the vendor. Requirements in the sense the specification. So all these specifications are tabulated in one document, which are called as the MR, material requisition. Then we give this document to different vendors. Okay. Now, if you want to buy a mobile, will you go to a shop of a automobile or will you go to the clothing shops? No, you will not go to clothes. If you want to buy a mobile, you will go to the shop of the mobile. If you want to buy a clothes, you will go to the malls to buy clothes. Similarly, in piping, over a plant, if you see the what are different type of components, there are pipes, elbow, reducers, tees, then gasket, bolt, different walls, and each vendor does not manufacture all these items. You have different vendor for different category. So let us say the pipe manufacturer generally he will not manufacture the wall, you know, or the gasket manufacturer he will not manufacture the pipes. Even in the pipes, few vendors will only manufacture the carbon steel pipe. Few vendors will manufacture only the stainless steel pipe. So depending on the category also, I have to select the different vendors. Yeah. So there is a vendor list given by the client, and as APC consultant, we also give our recommendation to the client that these are the vendors which are known to me. Okay, like we say, if we want to buy something, then obvious we have some favorite shops which are known to us. Then we sometimes we give the recommendation. Okay, if you want to buy this, you go to this shop. Accordingly, as a APC consultant, we also tell them a client that for some different past project executed by us, these are the good vendors for these components. We request you to give inquiry to them to this also. So this MRI document will be sent to the different vendors. Okay. Then that vendor will review this document He will first check if he can supply this component or not. If he can supply, then there are next two steps. Whether he can supply the component as per our requirement, or he can supply some alternative. Alternative in the sense he will give some deviation. You know, like if you go for the if you ask for the Samsung mobile, then the shopkeeper will say no, no, I do not have a Samsung mobile. I have a MI mobile. Okay, then you as a customer have a choice to decide. Even though your requirement is Samsung, vendor is offering you MI. Is that MI mobile suitable for you or not? Similarly, the vendor will give a deviation and we will decide whether it is suitable for us or not. So all this process is called as a review the vendor offers. Okay. Then as I told you, there will be some deviations. Every time vendor will not give what we want. Because vendor also have his own standards. So in such case, we have to do the technical discussions with the vendors. And at the end, we will prepare one document which is called as a TBE. So as I told you, when you let us say when you want to buy a mobile, yeah, you will not go to a single shop. Let's say you will go to five different shops. You will ask for the same mobile, and everybody will give you the different prices. And which is the best price or the vendor which gives the best offer, you will select that vendor. Similarly, we do it here. We do not go for the single vendor. Yeah. And also it is not fair to select a single vendor. It is always recommended to at least have three vendors. So you can compare the prices and everything. So we should have at least three vendors. So this inquiry is sent to at least three vendors and then it's evaluated. Yeah. What are the other tasks of the piping material engineer? Coordination with other engineering departments, piping modeling. Yeah. So help 3D administrator in PMS creation in 3D software like PDS, PDMS. Nowadays it is called as E3D or the SP3D. So we as a piping material engineer, we have produced one document as a PDF document. But how it shall be used by layout engineers? It has to be transferred to the software. Then we always, when we are using a software in a company, we have different links. The software where which we use for the piping material specification, we can transfer the data from this software to A3D by single click. Yeah. And then piping stress, thickness change as per the stress requirement. So as I told you, the role of the piping stress engineer is to check the stresses developed in a pipe. Sometimes it is required to change the layout of the pipe to reduce the stresses, and sometimes we have to increase the thickness of the pipe. Okay, then then the stress engineer will say, okay, increase the thickness of this pipe or this component. Then we will increase the thickness of that component. Then process is the most is a department with which a piping material engineer has a very vast and the larger discussions, because process engineer is responsible for the PNIDs. Process engineer is responsible for the fluid list and to prepare the piping material specification. Fluid list is an input, because in the fluid list the process engineer gives the basic material, whether it is carbon steel or the stainless steel, and the design pressure and temperature. And obvious based on that we prepare our pipe classes and the corrosion allowance. In instrumentation, we have different instruments which we use in our piping whole plant. Okay, let us say pressure indicator. So what is the end connection of that pressure indicator? As a piping, we have to give the suitable end to that pressure indicator so that it can be get connected. Or sometimes the many of the times the instruments are the threaded, male threaded. So we have to give the suitable female threaded components to attach this instrument items. With the mechanical also, we have sometimes the coordination. Mainly, the coordination with the mechanical department is to decide the nozzle, especially 24-inch and above, because uh, I will not go at this moment too much deep. The flanges which we use in the piping, it has a they are used as per the ASME B16.5 standard. Above 24-inch, we use ASME